So yeah, let's start. So when I started to create my presentation, we were asked to come with a nice story about our company and everything, and I was reading articles on the web and found this one. Network automation is not an effortless spacewalk. Maybe you know the author and maybe you agree with what she's saying in the article. I definitely know that I did agree with most of everything until I started to think about, wait, who's the astronaut? Are we the astronauts? I don't think we are. Anyone is brave enough to step into the suit. So if we think that the astronaut is our clients, for them, the network automation should be an effortless spacewalk. They shouldn't care about anything that happened before the costume creation. So if we think as ourselves, as NASA, for example, who's building the spacesuits, what do they do to build to reach such an achievement to put a man inside the suit in the most unhospitable environment? So what they do is they develop a lot and they test, they test, they test, and they test. And this is something that I want to talk about in my presentation. So first, a bit of history. 3 years ago, my colleague Martin Gizzi was in this very stage. Actually, he was on the main stage, and he presented a topic of how we, as network engineers, we are going to evolve in the next, in the future, how we are going to evolve. So instead of doing all the stuff that some people are seeing, doing network engineering, software engineering, network testing, and all that, everything will be handled by a single person. So that's why from his presentation, I changed tomorrow to today, because that's me. And yesterday, it's in the past. Something that he mentioned here that we kind of do and kind of not do is this part, the automated tests are run. We have some, but we will see later how that happens. So about me, I'm Eugen Șerban. I'm a DevOps engineer, actually NetDev engineer at Swisscom since 2022. I'm a software engineer by study and a network engineer as well. So for me, this job, it was something that brought everything. And I also have testing experience. I worked at CXTA and at Cisco as well. Now, I love this picture because it shows what all of you know. In brownfield, this is what we have. Swisscom is the oldest and the largest service provider in the country. And you can see here networks for everything. We have, I don't know, internet, triple play, whatever you can imagine, there's a network for that. And as you can, the topic of this whole conference was brownfield. So what do? Do we start eating the elephant and try to reconcile all this? Or we tear everything down and build a network from scratch? We had the opportunity to do just that. Instead of reconciling all that, the network is built, and this is the network. It's all new, including the optical layer, and it's dual core. It's using all the modern technologies, SRv6, so it's scalable in the future. It's fully automated using NSO. Since we are greenfield, we don't need to reconcile everything, so everything is automated. The services that we provide are exposed via an API gateway. We are following TM Forum's recommendation, and we are split in ODMs. So ODMs are operational domain management, and the services are exposed via APIs. What this means is that let's imagine that we decide to tear the network again, tear it apart and build a new one. We can just do that. The API stays the same, and our customers don't care. They interact via the APIs. One thing that I didn't show last year when I presented this, by the way, it says 2026. I think we should have been bolder because my phone is running on this network, even though I'm in roaming. this is Swiss reality, this network. And to achieve this, we use the CXTA framework that was recommended by Cisco, and they created some tests for us that enable us to move fast and not break things, like I mentioned before. Who here knows what CXTA is? Okay, some hands. That's nice. You guys from Swisscom just, okay. Okay. So last year when I was on the stage, I was focusing more on the network developer. How does this person develop the network, the new services that we provide on the net? So what I have at my disposal when I create a service is a full copy of the Titan network in Container Lab. So I just press a button and it spins up. It's not the full network because it's impossible to have 1,000 devices. It has only one core and several aggregators and some metro and 2Cs. So I can have the full connectivity from A to B. I can ping, I can run my VPNs. L3 VPN, L2 VPN doesn't work, but it's good enough. I have my NSO in Docker, so I can do whatever I want on my computer, and if it doesn't work, I just tear it down and restart it again. And I have my CXTA container. I can run the test locally on my computer before pushing the code and let the pipeline do its thing. Why? Because we have so many tests, and it takes around half an hour for the pipeline to run, and I prefer to start it on my computer than wait for the whole pipeline to churn. Okay. This year, I want to focus on another guy. I would like to focus on this poor guy, because this guy has to make sure that all these pull requests are covered. So you can see here, we started in, it says on my computer, 2022, yes? So we have 852 pull requests. That means it's around 1 point something pull requests per day. And the network tester has to create his tests, or at least run the tests that validate that whatever this network developer didn't break the existing functionality, and he has to create a new test that cover the new functionality. Of course, that was a very tedious process, and at some point, it happened that we had a feature, a very complicated feature that we started last year, right before I left this conference, and the development for it was done around August, September. It was pushed in production in October, and the automated test for that, it was done in January. Okay, so what did we do? We created a new framework because we like graphs and we like colors, and this is it. Okay, I would like to focus on this middle part because this is where the magic happens. We have all the three roles that I showed earlier. Here we have the network architect. He does the configuration on the devices. He does the manual tests and everything, and make sure that the templates that he provides to the network developer are correct. He also creates the roadmap for the migration plan, if there's any. Then the NSO developer creates the NSO code. So that's the XML template, the Python code, and the unit tests, which are automated. And then, at the same time, the test automation guy should create his test. And the pull request is accepted by us when all three people have reached the same stage. And that means that we don't have the same case like I mentioned earlier when we have a feature that is pushed in production and is not covered by automated test. Okay? So we thought, okay, you know what? This kind of looking at things has a name in the software development industry. It's called test-driven development. So let's slap a label on it because it's agile and it looks nice to the higher-ups, and we can get some buy-in. What this means is that the test code is a production code. What I mean by this is that test code should be a first-class citizen. There should be merge requests. There should be code reviews. There should be unit tests. Even if it's test code, we should test our tests. And it should be modular. We don't want to have the same functionality in several scripts, several tests written, I don't know, several ways. One of the things that we do the most often is show interfaces, right? You want to see if the interface is up. If everybody does that, I mean, for show interfaces is fine, but if you do a show neighbors, you have to do a parser that parses the show neighbors for everybody. And let's imagine that, actually it's not even imagining because it's happening even with netconf, the show command changes, right? So what do? You have to go through all the scripts and change the parser again. If it's modular, you change it once and everybody can benefit. Also, creating a parser is a tedious process. It takes around half a day. So if I create a parser because I needed, I don't know, show ISIS adjacency, for example, my next colleague can take it and just use it, and he can continue with his own tests. Right. All this can be done with robot if you are an experienced skill developer. And I will touch on this phrase later because it will come in hand. Now, like I said, we had tests, and this is a screenshot that I took from a batch last year. I think it was in October or something, and we have a lot of tests that are failing, okay? This usually means that your network is down, right? When you see everything is failing, what's happening? So we went to look at it, and the tests were failing because a new device type was added in the network. And this is something that always happens in a network. The network is a live organism. Stuff comes, stuff goes away. And the problem was that the tests, they were expecting a specific state, like, I don't know, you take a picture and this is the network, which never happens, okay? So we stopped and we said, okay, what do we do now? Let's take what's good from the test-driven development. Let's try not to be too religious about it because still we are network engineers and software development, it's, you know, not our job yet. And see how we can move forward, okay? And we did a internal study to figure out why we reached this test. And what we found out is that the test automation was not structured. Like I said at the beginning, test code was not first citizen code. Everybody was doing his own thing, whatever, they were just pushing tests there. And there was no idea. And the second one, network developers didn't see a reason to learn robot after having to learn Python. I don't remember if it's in the same article like the one with the astronaut or in some other article from the same author, but she said that we are network engineers because when we finished university, we didn't want to be software developers, right? But we still want to work with computers. Computers are fun. We want to work with that. But times caught up and we had to learn software engineering. And for some reason, whatever, I don't really care, Python is the go-to language for software developer in our field, in network engineering. So all of us had to learn Python. Why would I have to learn something else? Especially robot, which is a wrapper over Python. So I had to learn Python to build my NSO code. Now I have to learn something else, which is sold like making creating tests feel easier, but I have to deal with all the complexity of NSO. So complexity doesn't scare me anymore. I don't want to do something which hides the complexity. I will go all in. And then we thought about it. Okay, so now we need a structure. So let's do that. And we need to deal with people's appetites as well, because in the end, it's the people that will use this. For now, maybe AI will take over and we can all retire and that's it. But until then, we created a set of requirements for how we will choose the next framework that we will use for our automating tests. One of the first things that we wanted, it must be open source. Why it must be open source? Usually that when you have access to the code, you can modify it and you can understand it better. You know what it does because you see it. We learn how to read the code. It must have extensive documentation. For CXTA, it was you have the keywords only in NTM, but we wanted to have Git books. We wanted to have YouTube video. We wanted to have even physical books if they exist. We wanted to have blogs, everything. It has to have extensive documentation. It must use a language that network developers are familiar with. This one is self-explanatory. It means it has to be written in Python. Okay. It must already be used by another team within Swisscom. Why is that? Is because if there are other people inside of our company that are using it, the buying is easier. And I have here colleagues that used pyATS because for them it was the easiest. And we say, okay, if for them it's easiest, maybe we have buy-in from other people because it grew naturally in their team. And also, it should be able to handle CLI, netconf, and REST. Why? Is because, so our first network, the Titan network, is based on ISXR, and we are only using netconf to interact with the devices for everything. Everything is using netconf. But the second network is based on Huawei. And the netconf nets for Huawei are iffy, okay? So there we use CLI. So we had this, CLI, netconf, REST. And the rest is, we wanted all the other services, all the other systems that we use to orchestrate our network to be able to be included in our test cases. And those systems are the inventory. Our inventory is based on, so the internal inventory for us developer is Netbox, which has a REST API. Actually, it has a REST, it has PIP packages, so that was easy to integrate. And for production, we have NDO, which also has a REST API. Then we have the northbound orchestrator, which has a REST API. So we wanted to test the full chain. We wanted, depending on the stage, to have the test that the user will do in production. Okay, so when you create an L2 VPN, nobody is going to go on NSO and say, I want to create a VPN like this. No, there will be an orchestrator somewhere. There will be an order. We wanted to include the full chain. And the idea was, we include this particular step depending on the stage that we are in. So we ended up with pyATS. And because we ended up in pyATS, we could do these things, which is something that the management always asks about. Okay, so we have this test that we use for Titan. Why can't we take the same test and slap them on Huawei? Because it's the same technology, same SRv6, the nomenclature is the same. In theory, it should work, but it didn't. So in pyATS, our tests are stage agnostic. It means that the same file runs on my computer, it runs in the dev test pipeline, it runs on integration, it runs in end-to-end, pre-prod, and production. Same test, There's only something that will change, and I will show you during the demo. Tests are OS agnostic. Like I said, not only do we want to be able to switch between iOS XR and Huawei, we also want to switch between versions. We want to be able to switch from, I don't know, version 7.10 of iOS XR to 24.4 or whatever, right? And there are things that change between, even inside the same operating systems, there are things that change between versions. And I gave ISIS as an example because we just found out that for the version that we want to put in production, the ISIS schema, so the young schema changed a bit, so we have to review our parsers. But the test shouldn't care. The same test should be able to run. We will just adapt the parser or create a new one, and the test should be able to pick up the correct parser that handles that specific OS. And also they are connectivity agnostic. This means that we can interact with the device via netconf, restconf, directly on CLI, it doesn't matter. The test shouldn't care. They are automatically discovered. Okay, so I have 13 minutes left, and I prepared a demo, which I would, if you can switch to my computer, please. Nice. Okay. So the first thing that we do when we create a test, we start with a use case. And I will start with something that doesn't have any resemblance with actual things that happened in our networks, or the usual disclaimer, all similarities are purely for sarcasm, right? Non-stop routing. Let's say somebody did a big whoops and forgot to implement non-stop routing in the network. Okay, so we want to add it in our NSO code, and then for the next NSO release, for the next Titan services release, that will be pushed everywhere in the network, right? So how do we test this? What I have here is a skeleton of the test. It doesn't have anything. Who here knows pyATS? Okay, one. So when you create a test, the first thing that you need to think about is what are the steps that I'm doing before I'm starting a test. So that's the usual stuff. I connect to the device. That's a step. I check that something is in this state. Okay. At the end, you do a cleanup. What you do, you remove all the junk that you put in the network. In your test, I don't know, you want to create a VPN and test that traffic flows from A to B. You don't want to leave that there because who knows what happened, and unused code is the worst kind of code, right? So you want to remove it from the network. Now, is it big enough? Can everyone see in the back? Yes? Okay. Okay. So, like I said, it has to be modular. For the common setup, the things that we all do are the same, right? So we have a module here which is called Titan Common Setup, and we just import that, and we let the magic of Python and polymorphism and all that kind of stuff to take care of it. And to look what this common setup does, we have a nice documentation. For people that know pyATS, they recognize this interface. It's Sphinx. So the common cleanup does the following. It loads the testbed. We will see later what the testbed is. It connects to NSO. What this means that I am able to reach NSO, right? It checks the NSO packages version because think about it. I create my test here and I push it, but maybe this test tests something that will be available in the future. So I want to make sure that I don't do a test that is not supported yet. So I check that the package version of this test is equal or higher with the package version that I want to test in my environment. I get the test environment. Like I said, the same thing runs in all the stages. I load my test data. I connect to CP broker. CP broker is the northbound. It's the boss of all the VPNs in our network, right? So if I want to create if I am able in my current stage to create a VPN from CP broker, I do it from there. If not, I will skip this step. I make sure that my devices in NSO are in sync. I check that day one is in sync. I get a rollback ID, and I get the rollback ID because at the end of all this, I roll everything back. So I'm using the magic of NSO to undo all the stuff that I did, right? Okay. So what else do I need to do here? So the way I like to start creating my test cases, I create a test plan. So I have all the stuff that are common in the Titan test common, and I keep adding stuff. So it's non-stop routing, okay? I need a step where I pick a router. I know that for NSR to run, it has to be a router that has 2 route processors. And in my network, there are several roles that have this functionality, and one of them is the route reflector, right? The most important device in every network. So I will pick randomly a route reflector. Then, and this is something that I like about Copilot, it's reading my mind. Yes, I want to connect to the router. Yes, no, I don't want to. I don't want to extend, and I think this is enough. Now, I move to the next, to the actual test. So we have in the common, in the setup, because this is something which is common for everything, and now for my specific test. Make sure the router is not connected to NSO is, let's call it NSR ready. What this means is that both RPs are up and running, right? Because if there's, I connect to a router and there is only one RP, if I crash it, I mean, everything will crash. So it doesn't make any sense to do that. Check BGP state. Well, check BGP state, actually get BGP neighbors. Yes, let's do that. Check BGP neighbors state. I love AI sometimes. Now, crash BGP process. Crash BGP process. And then check again the neighbor state. So for NSR, the neighbor state shouldn't change, and the established timeout should keep increasing, right? So this is something that I will check. I will check that the state is still established, and I will check that the established time is higher than what I had before in my common in my setup. And in the common cleanup, I don't do anything because rolling back is enough. And then I just start tab, connect to router. No, actually, this is not something that I want to do. I want to pick a random router. So from the test bed, I will do something like this. Error names equals device name is, we call them error local. Okay, good. Now error name, we said that we want to pick a random one. Random choice error name. Yes. Hey, it's even adding logging. Now, it's not self-device because that's not how pyATS works. It's device equal, and there are several steps that you need to do to connect to a device, and it's always the same. And I will just use this nice function that we created for everybody to use. And it's error name, testbed, and steps. So we should add steps here. Right. And then, because it's pyATS, self, parameters, device, no, it's not like this. Update device equals device. Okay, this was nice. By the way, you can stop me at every step. So since it's a demo, yes. Anyway, the test will fail. So where did I, here, error local, yes. And also here, I forgot to import random, for example. Import random. It will fail somewhere else. Now, it's not a test, it's setup, right? And def setup, check, yes. Okay, and this one I forgot how to do, but fortunately I made the documentation here. Okay, so it's this one. Like I said earlier, we have modules for everything. So the test is easy to create. So what this will do is it will pull the device every 5 seconds for 12 times. So that means 60 minutes. And it will check if the redundancy is ready for running our test. And I want to assert this. And if not, router is not NSR ready. Good. Now, test. Get BGP neighbors. Okay. BGP neighbors, assert BGP neighbors, for assert neighbor state, BGP state established. Okay, this one looks good. And you see here, this is something that makes BGP state be OS agnostic, because in Huawei, no, in OpenConfig it's called established but with capital letters, and in iOS XR is called established but established with capital E, and the rest is, so we created a mapping for this. Okay, and what I want to do, I want to note all this on a piece of paper, which is something that you would do as a manual tester. So I would say device custom for BGP crash. Okay, BGP neighbors. Okay, so what this means is that whatever I got here, it will carry over for the next test. I have 1 minute left. Okay, anyway, you got the idea. So this is how we are creating the test. Now, I said at the beginning that this is not resembling real life, but actually we did forget to put NSR in our network. And we discovered that because we are doing something which is called REP. It's a reliability enhancing procedure. Those are automated tests that run in production. And they are created using pyATS as well. And they do stuff. And one of the things that they did was crash the process. And what happened, and my colleagues were awake for 2 nights, an interface stopped forwarding traffic. And then we discovered this again, right? And then what I think is this test, I created a test that checks something. So we discovered that if we create a VPN 10 times and then we crash the process, and then we create a VPN 10 times and then we crash the process again, the 21st time, traffic will not be forwarded on that interface. And that was a bug that fortunately was fixed very fast by your colleagues at iOS XR BU. And that's how we discovered that NSR was not ready, because I wanted to crash the process and not switch over the RP. Awesome. That's it. If you have questions, I will be outside.
Thank you very much.